Today's video is Science is Stupid, and I know what you're thinking. This is either a clickbait title, or I'm just some right-wing crackpot evolution-denying anti-vaxxer global warming supporter, right? Correct. Now, if you talk to anybody in higher education and you say science is dumb because of this and that and this and that, it's just like democracy. What they're going to tell you is literally the exact same democracy quote. While science may be bad, it's the least bad of all truth-seeking mechanisms. I'm going to argue that that is nonsense. Now, when you confront educators and scientists why the scientific method is good, you would be surprised how often it comes down to Galileo outsmarted Aristotle 600 years ago. Now, Aristotle was a philosopher from 2500 AD. Aristotle said that women had less teeth than men. Much like when they tell you the only alternative to a democracy is a tyrannical dictatorship, they tell you the only alternative to science is some kind of crazy homeopathy or religious nonsense. What you should be doing is taking many top intellectuals and having them design their own truth-seeking process, and then comparing the results. Maybe even the scientific method would show other methods produce higher results of accuracy. The very first thing that they teach in introductory psychology is that the scientific method is the best truth-seeking mechanism, yet there's no citation or evidence to support this claim. That seems very absurd. If the entire textbook is built on science, shouldn't proving that science is a good truth-seeking mechanism be an important thing? Now, before we start this video, I'd like to say I do not support most of the anti-science community. Most of the anti-science community is insane. And they're the kind of people who just say, you're a scientist, everything you say is just a bunch of corporate crap, I'm going to throw all your research into the garbage, I'm not interested in anything you have to say, I'm not even going to listen to your arguments, I'm just going to say you're wrong without even having listened to you, right? That type of attitude I do not want to encourage, I do not want to promote that. Now in this video, we're going to be focusing a lot on getting risk right. Now, should you buy this book? I'm going to say probably not. I shouldn't discourage all these book sales, but if you're not super ultra interested in whether cell phones give you cancer, brain cancer specifically or not, then I would not recommend buying the book. Alright, so the first thing we're going to look at is peer review. Peer review is a very popular idea on the internet. If something is not peer reviewed, then it probably does not hold intellectual weight. And I assure you, this opinion is peer reviewed. So for those of you who don't know what peer review is a process where you basically send your findings to a bunch of other researchers. They check the quality of the research and they give it a stamp of approval or an F. Now, isn't everything that's published in a scientific journal peer reviewed? The answer is no. In some very low quality journals, they'll publish something even if it fails a peer review, but generally passing a peer review is part of the scientific process. Alright, so there's not a whole lot of meta research about peer review, but there is some. So let's look at the research. This is a study by Richard Smith, and in this study what they did is they sent 2 papers in to reviewers and they packed them with flaws and mistakes. And on average, the reviewers caught 25% of the mistakes. So 25% is way less than half. That's pretty bad. Some reviewers caught none of the mistakes, and none of the reviewers caught all the mistakes. Now, you know how the science community is militantly trying to fight the anti-vaxxers? Well, the anti-vaxxers came from Andrew Wakefield, and he's the guy who published a study that vaccines cause autism. And his study was peer-reviewed, and it passed peer review. Science, to a large extent, created its own worst enemy, and you can see the exact same thing happening with coronavirus. It was the science community who was telling everybody, don't wear masks, the masks aren't very effective, but peer review is still catching 25% of mistakes. 25% is better than 0, right? Wrong. No, that's right. But peer review is an extremely popularity and political based process. So what that means, for example, is let's say you do a study and the results of your studies show that we shouldn't care so much about the environment, environmental issues are overblown. That's going to be a very unpopular position in the science community, and that's almost certainly going to fail at peer review. So while peer review is catching some errors, it's also systematically filtering research to be more erroneous. Scientists are not paid to do peer reviews, and they're often going to do a very sloppy job. In fact, it's very normal for them to not even check references. Now, the next major problem in science is sensationalism. This is where people like to publish sexy, interesting findings over well-researched, accurate results. And if you ever watch TED Talks, you'd probably get a very, very strong sense of that. Scientific funding depends very heavily on public interest, and public interest depends very heavily on news media sources and sensational science. Now, is the problem of sensationalism the fault of a whole bunch of corrupt scientists, or is it systematic? The answer is it's systematic. The system incentivizes publishing a whole bunch of crappy research. Now, you could ask my dad. He worked in academia 50 years, and there's a much, much, much higher emphasis on the quantity of research you can publish than the quality. Well, that seems insane, and the reality is, in order for scientists to keep their jobs, they have to be publishing high quantities of work. Statistical errors and false alarms are actually more likely to get published. Most published scientific findings turn out to be wrong. Both scientific journals and media outlets have an extreme bias against null results. So what exactly is a null result? That sounds like a bit of a fancy word. So a null result, I'll give you an example. Let's say you did a study on whether potato chips cause cancer and you found there's no correlation. That would be a null result. A positive result would be if you found there is a correlation between potato chips and cancer. Now, because null results are ignored, if you're reading scientific journals or media outlets, you're going to have an extreme bias towards positive results. In 2005, they did a study in biomedicine and found 50% of published research findings are false. And I know they doesn't mean much, but the they is in the Steve Patterson video if you want to know who they is and get an actual citation for that study. It's common for researchers to not actually even read the research that they cite. And this goes all the way up to the level of the CDC, the Center for Disease Control, which is supposedly one of the highest authorities of good quality research in biomedicine. Now, this is not a fault of the scientific researchers. This is a fault of the scientific method. The system itself is fundamentally flawed. And a good system should take into account funding biases. It should take into account political biases. The scientific method is a bunch of rules and guidelines for conducting better experiments, yet it's clearly lacking some of the biggest human biases. Now, another key aspect of the scientific process is replication, and that's again another fancy word. What is replication exactly? So, let's say I conduct a study using process X to determine whether Doritos gives you cancer, like the chips, Doritos, right? And I find the results are overwhelmingly yes. Then another scientist on the other end of the planet should be able to follow process X and do exactly what I did and get the exact same results. If they're getting different results, well, then that shows one of the scientists probably isn't doing something right. Now, people pick on psychology a lot, but to a large extent, psychology is actually better than a lot of the other scientific fields because psychology acknowledges that it has faults and tries to actually correct them. Open Science Collaboration did a massive study where they try to replicate the body of knowledge in psychology, and they found that only 37% is replicable. So that is a bad sign. Now, in science, the whole career structure largely impedes the replication process. There's actually extreme incentive not to replicate studies or to inaccurately replicate studies. Now, this is because if you're the guy who goes out there and tries to replicate everything and you find that most studies can't be replicated, this is going to build you very bad karma in the science community. What most scientists do is this system of politeness called conceptual replication, where what they do is they replicate a study but they change it slightly. They change their methodology slightly so that if they do find it failed replication, then they can't precisely pinpoint why it failed replication. In short, making the replication useless. What about scientific jargon? This may sound like a superficial issue, but I think it's actually a really deep and fundamental problem. Science should be as easy as possible to learn, not as difficult. Remember taxonomy? A lot of the study of biology used to be nothing more than renaming animals in Latin. And to a very large extent, this sort of thinking is still applied. For example, in medicine, a very large segment of what you're doing is simply learning how to call body parts in Latin. Science should be very logical and intuitive to learn. I really don't think most of these things have a point. I know the Latin definitely doesn't. In my human anatomy textbook, it says that people literally die as a result of confusing Latin terminology. Tribalism and dogmatism are also huge problems in the science community. It's very rare that people ever investigate their foundations. So, for example, if you were to go into biology, if you were to question something like, the basic theory of genetics, the basic theory of evolution, these things are all just taken as dogma. You don't even waste time questioning these things. You just start building and building more and more layers upon these bodies of knowledge. And no, I'm not an evolution denier. I just picked it as a random example. Darwin was wrong about it being survival of the fittest. Clearly, evolution is survival of the fit. But let's not start that debate. Maybe I'll make a whole video about that. Blah, blah, blah. My job is done. I don't like videos with notes. It's annoying reading off a note card. If this information is not enough to make you become deeply skeptical of science, no matter how much data I provide, it's not going to change anything. So enough with my research. What do you think? Do you think that science is the best truth-seeking mechanism, or is the least bad of all truth-seeking mechanisms? Or does science just suck and there's probably something way better, but because of dogmatism, conformity, and religious-like attitudes from the public and the science community, it will never progress? Now I know people are going to say, if science is so bad, why don't you design a better system yourself? And maybe I would. Maybe I will. Maybe I will. No, I won't, because the last time somebody told me to do that was with democracy. They said, if democracy is so bad, make a better system yourself. And I took the time to draft an entire government system. And did they read it? No.